Hi, everybody. Welcome to the Shiko SAT review series. In this unit, we're going to review a very important topic. And this topic is how to solve the system of equations. This is a super important topic for the SAT exam. I look back for the past 10 years of all the SAT exams. Every year, there are at least one or two problems in the exam and related to the how to solve the system of equations. So that's why I like to focus in this unit, and I'm going to divide this unit into 3 videos. So you'll be able to see each video going to teach you some different things about how to solve the system of equations. So in this unit, I'm going to discuss the typical method we learned from algebra is how to use the elimination and the substitution method to solve the system of equations here. And also then the next topic we're going to talk about is, this is the topic a lot of the students has trouble with, is they have the problem for the system of equation, and they will tell you, say, hey, if this system of equation has no solution, then they want you to find the constants or coefficient in front of the variables to see which variable, which coefficient will make the system no equation, no solution. So this is kind of like the it's kind of like the topic I think the most confusing to the students. Okay, and then the other topics we're going to cover in this unit is how to simplify the system of equation with decimal or fraction coefficient. This is another problem so student encounter, is because for those problems typically they belong to the section no calculator is allowed. So with the decimal and the fraction, and make your computation is very tedious, and you will easier to make a mistake. So I'm going to show you how to simplify that and then how to do that. Okay, so in here, like I say, I'm going to divide it into 3 videos, and we're going to talk about the different topics, and also I'm going to show you some tricks what you can do to solve this. Okay, so this is the first set of the problems here. We're going to have 7 problems here. So when we finish this 7 problems, we're going to, stop here. Then we're going to go back to, our next ones here. As you can see, the next ones here, we are combining, we have a total 6 the 6 problems, and the 3 of them involve the fraction and the decimal, and then another 3, instead of linear functions, one of the function is quadratic. Then how do we do that? Okay, then the last videos here, the last video is going to talk about the one I talked about before. A lot of students got confused about it, is if your system equation, they say there's no solution, then they want you to find the coefficient in front of the variables, so which cause the system of equations has no solution. All right, so that's what we're going to do for this unit here, okay? So now, and I'm going to go to the whiteboard, and let's start to work on the first videos here. Okay. Okay, so in order to do the first video, and let's do a brief review. What is the substitution and elimination method, and which one was like you learned in the algebra, and just try to refresh your memory a little bit. So when we talk about the solve the system of equations, like I mentioned before, we typically use substitutions or elimination method. Personal, I like an elimination method because I think the elimination method is easier and to do. But you know, if you are familiar with or comfortable with the substitution method when you learn your algebra, feel free to use the substitution method. To me, the substitution method has a little bit more chance to make some silly or careless mistake. So personal, I like the elimination methods here. Okay, so let's take a look here. Right? So I'm going to use this example to show you what do I mean the elimination method or the substitution methods here. So let's do the substitution methods here first. Okay, so the substitution method is basically I'm just substitute one of the variable with the other to the different equations. So the tricks here is which variable to use. You know, you want to avoid the fraction and the decimal. So you want to find a variable just by itself. So in here you see, hey, this one's here. Look, this is a good candidate, right? So I can use this, you know, I can do that. So you will say this is a 4x minus y equal to 3, right? Okay, so now you can say the 4x minus 3 equal to y. You just move the y over. So that's why you can substitute. So then what you can do is here, you can substitute the y back to your what? Your first equations here, right? So your first equation, this is 2x plus 3y equal to 12. So this is 2x plus 3. Then you have, this is 4x minus 3, right? Equal to 12. Then you use the distributed rule. Then you say, okay, so here in here, right? Okay, now you will get this is 2x plus 12x minus 9 equal to 12 here. The reason why I said a substitution method sometimes is easier to make a mistake is when you use distributive rule or you miss out a negative sign, positive sign. So those things will kind of get you the wrong answer. Okay, after you do this, this is pretty simple. So 2x plus 12x, you will have 14x minus 9 equal to 12, right? Now you can plus 9 on both sides. So you will get a 14x equal to what? 21. Then you can divide by 14 both sides. So what do you have here? X equal to the 21 over 14. So if you simplify this a little bit, divided by 7, both on the denominator and numerator, so you will get 3 over 2, right? So you get the x equal to 3 over 2. Then you can substitute the x back to any equation you like. So I said 2x plus, or maybe I use 4y, maybe that's easier. So I will say the 4x minus y equal to 3. Now I substitute x equal to 3/2. So it's 3/2 minus y equal to 3. And then in here, this is 2 and 4 cancel. You got 2's here, right? So you got 6 minus y equal to 3. That means 6 minus 3 equal to y. So you get what? Y equal to 3. So your solution here is 3/2 and 3. Okay, this is what we call these substitution methods here. Like I said, in the high school, you learn both. In the personal, I prefer elimination. Okay, the reason why I prefer elimination because I want to prevent, you know, I going to make a mistake when I do the distributive methods here, or, you know, like if I cannot find any single variables here, then I think elimination will be better here. So, okay, so this is my equations, right? So this is 2x plus 12. This is 4x minus y equal to 3. So elimination methods basically tell you you want to eliminate one variable. So here, so I look at here, I say, hey, here's a negative, here's a positive, here's a 3, and here's a negative y. So I will say, okay, what I can do is here, I can times 3 on the both sides for these equations, right? So what I have here, so I have 12x minus 3y equal to 9. Then I did not change anything in my first equation. So my first equation is 2x plus 3y equal to 12. Then what you can do here, I say, hey, this is another thing I like because now I add it, right? So I add it, and then I will say this is 14x. And so what happens to here? These two cancel, right? So I can say 14x is equal to what? 21. Then you divide it by 14, divided by 14. So x equal to the 21 over 14. Then you divide it by 7 to simplify it. It's 3/2, right? So that's what I mean, the elimination methods here. So x equal to 3/2. So the same way you can plug back into one of your equations, right? So you will get the same thing. So when you plug back in, so you will get a y equal to 3, right? So you will get the same answers here. And but like I said, personal, I like elimination method because I can see I just use the add to cancel out or eliminate one variable, and then I can work on one variable here. Okay, so now let's take a look at some practice here. Okay, so now let's go to the okay, so here is our, the problem A, B, and C here in the, in the introduction slide, you can see that. Okay, so in here, I want to show you a few things. First things here, like let's take a look at problem number A. You have 2x plus 3y, 3x plus 2y. Okay, then the problem asks you to find 5x plus 5y. A lot of students, when they see this one, they immediately jump into, oh, I'm going to use a substitution method. Oh, I'm going to use the elimination method. But I always tell students, before you jump into try to do any problems here, look at problems here. Just, spend about 15 seconds, look at the problem. Then look at what the problem wants you to find. The problem here, in here they say, hey, find the 5x plus 5y. Then after you look the problem, you say, hey, here, 2x, 3x is 5x, 3y, 2y is what? Is 5y. So maybe I don't have to use a substitution or elimination. So I see these relations here, right? And so this is 1200, and this is 3x plus 2y equal to the 1300s, right? Then you say, oh my gosh, if I add these two together, what I have here, 2 plus 3 is what? Is 5x plus what? 3 plus 2 is what? 5y. And what is here is 2500. And I got my answer. So this is what is 2500. Instead of you spend maybe several minutes trying to use a substitution or elimination method, then just look at the data first. So this is one of the tricks here. Don't directly just jump it, right? So you look at the problem to see if there's any quick way to get it, all right? So now the next ones here, let's take a look again. So these ones here, they say I have two system of equations, 1/2 y equal to 4, x minus half y equal to 2. I'm going to find the value of x here. And also for this problem, like some of the students, they directly try to solve the y and then substitute y to x. Yes, you can do that. But then if you look at the problem a little bit more careful, what do you see? You say, I have what? I have a positive 1/2 y. I have negative 1/2 y's here. Well, if I add them together, these things cancel. So you have this is 1/2 y equal to 4. Then this is x minus 1/2 y equal to 2, right? Then you say, oh boy, this is pretty good. When I add it, what happens here? Boom, boom, these two cancel, right? One is positive, one is negative. So what is the value of x? X equal to 6, right? So these ones here, that's why I said do not just jump it directly to it, all right? And so you observe the relations here. Of course, if you use a substitution or elimination, finally you will get the answer. But remember, the SAT is it's a timed test, and you need to get the problem done fast. And so typical, the problem is not going to be over difficult. If you also like some of the problem looks difficult, but if you see the tricks there, you see the patterns there, you should be able to solve it very easily, right? Okay, so now let's take a look at the other ones here, part C. So in these ones here, I have negative 3.5, 9.5. Oh my gosh, those decimal. Then you read here, they say find the value of y's here. So like I said, spend 10 seconds, look at the problems. See what the good things did you see. Then you say, I'm going to find the value of y. Hey, here is 1 is negative x. This is a positive x. It looks like I might be able to cancel that. So you say, okay, this is x plus y equal to negative 3.5. And this is x plus 3y equal to the 9.5. Okay, now you what? You add them. So when you add them together, negative x, x cancel out. What is y plus 3y? It's a 4y. Okay, so 9.5 minus 3.5 is what? It's a 6. Okay, now you divide by 4, divided by 4. Y is equal to what? 6 over 4. And so it's 3/2. All right, so that's why in here, for these problems here, if you see the pattern, and instead of just jumping into the elimination or substitution methods here, you can get the answer way faster. That's why I always tell students, they always have some of those super easy problems in the exam. So you need to look at the pattern first to see you can see anything obvious instead of just jumping to solve it by using the elimination or substitution methods here, all right? Okay, let's take a look at these ones here. Okay, so this one, so I have 2x minus y equal to 8, x plus 2y equal to 4. I'm looking for x plus y. All right, so if you look for x plus y, so this is positive 2y, negative y. Well, yeah, you say, okay, if you add them, you get a y, but then here, this is 2x, x. That won't help, right? So probably this one, I will need to use the substitution methods or the elimination methods here, right? Okay, so now also I said here, you say, hey, here is a negative, here is a positive, right? So like I said, I prefer the elimination method. So what I will do is here, I say, okay, the first equations here, right? In order to eliminate y, what I need to do? Well, I said, hey, that's me times 2 on the both sides. So when you times 2, so what is the first one here? Well, 2x, 4x minus 2y times what? It's 16th, right? Now, you carry over your second equation is x plus 2y equal to 4. Then what you do here, you add them together. So when you add them together, what happens here? Negative and negative cancels, right? So 4x plus x is how many x? Is 5x equal to what? Equal to 20. Now you divide by 5, divided by 5. So what is x here? X equal to 4. All right. So after you get x equal to 4, then you substitute back to any equation. So I substitute back to the second one. So x plus 2y equal to 4. So then what I will have x plus 2y equal to 4. Then I will have what? I will have 4 plus 2y equal to 4. So you minus 4 minus 4, you will get a 2y equal to 0. So y equal to 0. So what do they ask us to find? They ask us to find the x plus y. So it's 4 plus 0 is equal to 4, right? Okay, so that's what the, this is what you you use the elimination method to find it. Okay, so the next one's here. Okay, so next one's here is like you look at these equations here, and then you say, oh, okay, 3x plus 4y equal to the negative 23, 2y minus x equal to the negative 19. When they put the problem like this, they try to confuse you. They try to trick you here. So the first thing here, we said, let's try to align it better, right? So x with x. So I'm going to rewrite this is 3x plus 4y equal to the negative 23. And in here, they switched it. They said 2y minus x. I was going to put x plus 2y is equal to negative 19. So now I can look better. I will say, okay, I have x to x, y to y. Then the same way, I'm looking at it and see what type of pattern. No, not a specific pattern, but here this is a positive 3x. This is negative x. So I said, maybe elimination method can help me. So in order to cancel the x, I can times 3 on the both sides, right? Okay, so if I times 3 on the both sides, the first equation now changed. 3x plus 4y equal to negative 23. Okay, so now let's take a look. If you times 3 on both sides on the second equation, this is negative 3x plus how many y's here? 6 y's here, right? And what I have 3 times negative 19 is negative what? 57 here, right? Okay, so now you can add it. The reason why, like I mentioned several times, the reason why I like elimination, because I add it, so the chance to make a mistake is small. Okay, so now the 3x cancels, right? So what happens here? So this will be 10y. Okay, so negative 23 plus negative 57 will give you what? Negative 80, correct? Okay, so now you divide by 10, divided by 10. So what is your y values here? Y value is negative 8. All right, so y value is negative 8. So after you find a negative 8, now you can put it into any equation. So I'm going to substitute to the second equation, 2y minus, 2y minus x is equal to negative 19. So negative 8, so it's negative 8 minus x equal to negative 19. So negative 16 minus x equal to negative 19. So I plus 16 plus 16. So the negative x equal to negative 3. So what I have here, x equal to 3, right? So I know the answer is 3 and the negative 8. All right, okay. So, okay, so the next one's here. I want to find the value of x here. All right, I want to find the value of x. So I'm looking at the values here. So, you say, okay, now I'm going to find the value of x. So I hope that I want to be able to get rid of the y's here. And also remember, we try to avoid the decimals here, right? So my first equation is x plus y equal to the negative 9. And then you look here, you say, hey, here this is positive 2y, here this is positive y's here. So how do I eliminate? You say, maybe I can times negative 2 both sides. Then see what happens here. Okay, so if you times negative 2, so this is negative 2x minus 2y. Negative 2 times negative 9 is what? It's 18. Then you carry over your second equations here, right? It's negative 20 what? Negative 25 here. It's good, right? So I can do what? I can add. So when you add, here cancel. So what is negative 2x and x is negative x. Negative 25 add 18 is negative 7. Then you divide by -1, -1. What is your final answer? X equal to what? X equal to 7 here. All right. Okay, so this is kind of like that's why I like I said, I like the elimination methods here. And I think it's faster. If you want to use substitution, that's fine. And there's no different ways, right? Some people is very comfortable. Then feel free to use the substitution methods here. Okay, so the part G is here, right? This one's here, right? This one, if you use the substitution methods here, probably you will end up with a pretty big mass because let's have the fraction. If you use the x equal to some y, you're going to deal with fractions all the ways, right? So probably, I think for this problems here, the elimination method will be way easier. So the first thing is you observe, you watch this equation, you say, it's pretty good. This one have a 3y, this is a negative 3y. Well, looks like it's very easy to eliminate. So this is 3y equal to 8. So this is 6 minus 3y equal to 5. Right? So now you say, hey, this one they already did for us. It's good. So it's a plus. And so when you do a plus, so here cancel. And what you have here, you have a 13x, right? So you have a 13x equal to 8 plus 5 is 13. So x divided by, I'm sorry, not divided by x, by what? By 13, right? By 13 and the 13. So what I have here? X equal to what? X equal to 1 here. Right? Okay, so x equal to 1. Now you can substitute to any of the equations. So I would say I'm substituted to the, let's say the first one, second one, doesn't matter. Okay, it's equal to 5. So 6 times 1 minus 3y equal to 5. So so I don't want to skip the step, so you guys can follow me. So this is 6 minus 3y equal to 5. And you minus 6 minus 6. So it's negative 3y equal to negative 1. And divided by negative 3 divided by negative 3. So what is the answer? Y is 1/3. So your solution is 1 and 1/3. Okay? So that's why I say for this problems here is super easy by using elimination. If you use a substitution, for example, if you say, hey, I want to use a substitution, okay, so like if you say the 7x plus 3y equal to 8, then you say the 3y equal to the a minus 7x, then you say y is equal to a over 3 minus 7 over 3x, then you substitute back to the second equations. It will be pretty tedious to deal with the fraction. That's why I said the elimination methods here, I will try to avoid the fractions here, right? So a lot of students, when they see, like if you end up with fraction, like something like this, the student already got scaled, and then the chance for you to make the silly mistake is very high here. Okay, so that's the end, the end of this video. I'm going to stop here, and so the next video we're going to deal with for the sum system of equation, they do have fractions, they do have a decimal point. How do I do it? Okay, so like I said, for the SAT, the key part here is how do you solve the system? How do you solve it quickly and correctly, right? And most of the problem, they're not going to be very tedious. All right, so you just need to find the better way to do that. Okay, so it's nice to talk to you, and so you can come back here for the video number 2. We're going to deal with the system of equations with decimal and fractions in the equation. How do we do it? All right, and so that's it. And it's very nice to talk to you, and so looking forward to talk to you on the second videos here.